Chapter 4, Section 17, General Principles in Growth Control by Heat. Now, it always drives me crazy. It's like nails on a chalkboard when I hear people who aren't in sciences use words that actually have scientific meaning and they just bounce them around and use the wrong ones because it sounds cool. You know, a couple of the words that really have specific meanings, especially in microbiology, are the words decontamination and disinfection. To decontaminate means you're going to treat an object or a surface, making it safe to handle. Okay? So you're basically getting rid of chunks, tissue debris, or whatever that may be on the surface of a cutting board. That's decontaminating. Disinfect means you are targeting the pathogens. Decontaminate means you're doing absolutely nothing to the microbes that may be present on that cutting board, that surgical instrument, you know, the tabletop in the lab. You wipe them down, you know, just to get to anything you may see off. Done. You decontaminated. To actually now use something that will actively damage, get rid of pathogens, that's disinfection. Alcohol, bleach, solutions. Those are disinfections. It's not going to get all organisms, okay? It's going to get some of the vegetative ones, species. It's going to do absolutely nothing to bacterial spores. It's going to do very little to, you know, fungal spores. But it's going to kill or severely inhibit some, not all. Well, that's very vague. Decontamination, disinfection. And another word they like to use is sterilization. Sterilization basically means you are getting rid of everything. You are damaging and destroying anything biological. All vegetative cells, all bacterial endospores, all fungal spores are now damaged, rendered to the point that they cannot become living cells. And it's not, you know, boom, done, because what method you use for sterilization, it will determine how long you need to treat things. What you're needing to sterilize will determine which method you use and how long you need to do things for. This level of complexity just get to you. I like to sit there. I really have to hammer away at this one when I teach microbiology for health sciences because it's nurses and they're going to be in the hospitals. And I always use stuff like surgical instruments. Okay, scalpels. You're going to be sterilizing those. Cool. They're metal. Usually it's a uniform metal, so you don't have to worry about warpage because of things heating up and cooling at different temperatures will cause certain alloys to bend and twist. So cool. But then there are other things that are going to be in the hospital that can't handle the high temperature, the high pressure, the high wet heat of autoclaves. So you're going to have some other methods for sterilizing them. If there's something that can't handle the wet steam, okay, you put it in an oven, and there are ovens that are used for sterilizing, and it's all slightly higher temperature, you know, like 150 degrees Celsius, and then you go for hours. Slow heat so that you drive off all the oxygen and basically you completely dry out everything. Okay, that'll work. So what you're doing is you're trying to figure out the reduction time. How long is it going to take to get rid of a certain amount of or all of the organisms? And then we also like to calculate what is known as a thermal death time. How long does it take to get rid of half? Because remember, yeah, you could take stuff and you could just toss it in the autoclave, crank it up all the way, and just let it go for hours. Well, then you can end up damaging whatever it is you're trying to sterilize. So you need a minimal amount of time to get rid of the maximum number of microbes. Different temperatures, different times needed to get rid of all of the organisms. So you can do it at low temperatures, you can do it at high temperatures. It's just gonna take time. If I got something that can handle a high temperature, I'm gonna put it at a high temperature, I'm gonna go for the lowest amount of time possible. Boom. Something that can be, thermal labile, high temperature is gonna damage it, 50 degrees Celsius, and then I'm just gonna run it for an hour. That'll still work. The autoclaves are great, okay? They're basically a glorified pressure cooker. Same pressure cookers you have at home probably. If you have one of those, Wonder Pots or whatever they're called. The autoclave uses pressure and steam. Turns out the steam was the big thing there. Because you can put stuff, like I said a few minutes ago, you put stuff in an oven, crank the heat up to 150 degrees Celsius, it'll still sterilize. It's just going to take days, hours, days. Because not all proteins will be denatured. Not all endospores will be damaged by the dry heat. But something about the wet heat that steam imparts. The high pressure means that you can take water well above the boiling point, 121 degrees Celsius. Under pressure means that it's going to denature more, if not all, proteins. This is how we kill endospores. This is how we irreversibly damage them so they cannot germinate. Don't care if they're, all those different coatings that we talked about in the previous chapter give them some ability to withstand heat. Wet, steam, heat under high pressure, still going to damage them. So it's not the pressure that's actually killing things, not the pressure that's damaging. The pressure is what's allowing the water to go to even higher temperatures than should be normal. Boom. Pasteurization is not an actual sterile thing. Pasteurization, things that are pasteurized means that the majority of the microbes there have been killed. High temperature, but low pressure. This high temperature, low pressure means that most of the pathogenic microbes will be killed. There's still some there, some microbes there, but the majority of them will be damaged. How long does this pasteurization take? What methods? Well, it turns out there's different methods. In Europe, other countries, they use a much higher temperature than we do, and they do it as a spike. I believe that's how they're doing it, spike. That's why if you go over to Europe, you'll see that their milk is sold in boxes on the shelf. It's not stored in the cooler like we are here. We do lower temperatures, and we do this up, down multiple times because it's cheaper. Just means that our dairy products are not shelf stable, and they need to be kept in the fridge, which is why our milk will spoil faster than theirs that's in the boxes just basically out on the shelf on the counter. Kind of cool. So when you look at autoclaves, here's the chamber. All of this you see here is all just to support the chamber in here. There's water jackets around this. They're going to be using superheated water to heat the interior here. Superheated steam is going to be released into this, which is going to cause the pressure to go up. Higher pressure means higher temperatures, okay? You've been taught 100 degrees is boiling. Well, guess what? You're going to go up to about 120. There you go, because of all this pressure means that boiling, water boiling, that temperature goes up higher. Lack of pressure means water boils at lower temperatures. That's why people who are climbing mountains have trouble cooking foods. As the jacket and the interior heat up, as you see here in the blue line, whatever you have in here, whatever liquids, whatever instruments, whatever glassware, whatever, will lag behind, but it will also heat up to almost, but not quite, 121, 122 degrees Celsius. The steam and the pressure will carry on for 15 to 20 minutes, depending upon what you set it to. And then the autoclave will slowly, over time, release the pressure, stop adding in the steam, release the pressure, which means the temperature will start to drop. Nice, slow, gradual. As it's going down, the temperature, or whatever you have in there, will also start to cool off. Notice it doesn't go back down to 0 or room temperature. It's going to take a while. How quickly you release the steam? Well, it depends on what you have in here. If you make it long and a drawn-out process because you have liquids, well, that's good. Because if you let this go too fast, all those liquids that are under pressure but at boiling temperatures will boil over and will flash steam. You'll lose half your liquids all at once. But hey, if you're working with instruments, say you're going to be in a hospital setting, MD, nurse, whatever it is you're going to want to do, or you're just going to be, you're working as a tech in the hospital and they have you sterilizing. Hey, guess what? You want to dry your instruments, your glassware quickly. Well, you have this go to it hits this point and then have it release the steam pretty much all at once. All that water that's collected on the surface of your glassware, your instruments, will flash boil off, be released with the steam that's being let out through the exhaust. Almost instant drying.